Okay, here we go with number 5 on our balancing redox reactions worksheet. So here we have some zinc metals, some aqueous nitrate, some aqueous tetrahydroxyzinc 2, fancy name there, and some ammonia. Alright, so the first thing we're going to want to do is split this into two half reactions. And the thing that catches my eye here is that the zinc bits are probably going to want to pair together, and the things with nitrogen are probably going to want to pair together. So let's try to set that up. Okay, there we go. So we've paired those up, and I've had some people come and ask me how they can tell whether one part or the other of the half reaction is the reduced or the oxidized when it's not super obvious. But you can really just split them up and figure it out afterwards. It's not super important to determine that now. So I'll go through this and show you how that works. So the very first thing you're going to want to do is see if your elements balance out, and we're checking everything except for oxygen and hydrogen at this point. So up top, nitrogen 1 and 1 balances out nicely here. On the bottom, you just have zinc and zinc. Balances perfectly. Okay, so now we can go ahead and balance the oxygen. Let's start at the top. So here we have 3 oxygen, so we're going to want to add 3 H2O molecules on the right to deal with that. And now we have 3 hydrogens here, 6 here, so we're going to want to add 9 hydrogens here to balance that out. Okay, so looks like the top is balanced. Now we can worry about the bottom. So here we have 4 oxygens, so we'll add 4 waters here, and now that gives us 8 hydrogens here, and we also actually have we have 4 hydrogens here, so we only need to add 4 to the right side to give us 8 hydrogens on both sides. Okay. Alright, so now we can worry about balancing charge. So let's start at the top. We have 9 plus minus 1. So our total for the top is plus 8. On the right side, both of those have no charge, so that's 0. So in order for the top half equation to balance its charge, you need to add 8 electrons to the left side, because that will give you 0. Okay, now looking at the bottom, neither of those have a charge on the left, so that's going to be a charge of 0 overall. Here we've got 2 minus, here we've got 4 plus, giving us an overall charge of plus 2. So in order to balance those charges, we can add 2 electrons to the right, giving us 0 here. So remember at the beginning when I said that it's not super important to determine ahead of time which half equation was reduced, which one was oxidized, because at this point, just from balancing the charges, we can tell that over here it gained electrons, so this one was the reduced equation, and over on the bottom it lost electrons, so that was the oxidized equation. Okay, so now we still have to do a little bit more, because right now we have 8 electrons on the left and 2 electrons on the right, and if you add everything together, those aren't going to cancel out nicely. So what we're going to have to do is multiply the entire bottom equation by 4. Alright, so now those electrons will cancel out nicely, and we can add everything together. Make sure you remember to apply that 4 to everything in there. Okay, so that's what we're going to work with here. The first thing I notice is that we have some duplicates on both sides that we can cancel out. We also have some water that we can cancel out here. So we can get rid of the hydrogens on the left entirely, giving us 7 of them here. And we can get rid of the waters on the right side entirely, giving us 13 on the left. Okay, so now that we've cleaned that up a little bit, if you were to check all of your elements and all of your charges for both sides, you'd see that they would all balance out. And if this were in an acidic solution, you would be done and this could be your final answer. However, the problem says that this is going to be a basic solution. So you're going to have to adjust it to accommodate that. So the first thing you're going to do is you're going to look at the H plus here. What you want to do is cancel that out. Well, you want to basically neutralize it by adding hydroxide, which will turn it into water. And you want to add an equal amount. So right here you have 7 of them, so you're going to add 7 hydroxides. And since you're adding it to one side, in this case you're going to have to add 7 to the left as well. Now, as we said before, these were going to come together to make 7H2O. And you don't have to worry about those in your equation anymore. The only thing left is to continue balancing out both sides, see if there are any duplicates. And you do have water on both sides, 13 on the left, 7 on the right. So you actually can cancel out all 7 of those, leaving you with only 6 on the left. So now all that's left to do is to rewrite this a little more cleanly. Alright, there we go. That's our final answer. And always make sure you go through and double check your elements and that your charges balance out for both sides. And then you can go ahead and box your final answer. There you go. Thank you for watching.